James kicks a soccer ball. The equation is h of t is a negative 1/4 t squared plus 4t models the height of the ball after t seconds. T represents seconds. Let's rewrite this as y equals. So we'll know how to put in our calculator. All right? So just a minute. Okay, here we go. So my A value is a negative 1/4, which is a negative 0.25, and B is equal to 4, right? So the first thing you want to do is like we did above. We want to press y equals, and we're going to put our equation in. So let's do that now, all right? Y equals, and we're going to put in a negative 1/4. So how do I know 1/4 is 0.25? 1 divided by 4, 0.25. So I'm going to put a negative 0.25 x squared plus 4x. And I'm going to press graph. Notice the A value is negative, so here is my graph. Now your graph may not look like this because I already extended my window. Your graph, if you reset your calculator, looks like this. All right, so why am I only seeing part of the graph? It looks like it's a line that's bent. Well, this is a soccer ball. Think of James kicking a soccer ball. It's not going to go underground in a negative underground. Think of this area as underground and all of this above ground. So we want to go to our table, and we see what happens. At 0, the ball is at 0. Then it's going up. See? It's going up. And it gets as high as 16. Then it starts coming back down. So if my window is at a negative 10, 10, I won't see where the ball hits its maximum. So the y value was up at 16. So let's make it 20. And the x was going up to 16. So let's make that 20. And we press graph. Here we have our ball modeled. James kicked the ball, goes in the air, and it comes down and hits the ground. We don't care about this because this doesn't make sense for the domain and range. We only care about where it's in the air and hits the ground. So, what is the domain and range of this function? We know he's on the ground, it's at 0. After 10 seconds, is at 15. They didn't tell us how high. I would say feet. At 12 seconds, it's coming down out the air. 15 seconds at 3.75 feet. At 16 seconds, it's at 0. So I see what happened. My ball went from 0 to 16 in 16 seconds. It went from 0 seconds to 16 seconds when it hit the ground again. What is my range? We can do this the same way we did the vertex above. So all we have to do is let's determine our x value, my axis of symmetry. That's what we're finding, the axis of symmetry, so we can find where it's the very top value. Be very precise. So x equals to a negative of b divided by 2a. My b value is 4 divided by 2 times negative 0.25. Let's put in our calculator and see what we get. Second mode to quit out the graph window. So we got alpha y equals. We're going to put a negative 4 divided by 2 times a negative 0.25, which is negative 1/4. Press enter. We get 8. So we know if we have the equation in y equals, we press second window, put 8 here, and press second graph. Our top value, our maximum value is 16. So we know the ball goes like this. When the ball goes like this, it has 2 boundaries. It doesn't just keep going, it stopped on the ground. So we're going to put a dot here and a dot here. So in this case, we have a bottom and we have a top. Now top was at 16, so we know our vertex is located at 816. That's my top value for y. That's my maximum, because this is a maximum. So y is going to be 2 boundaries in this one. It's going to be less than or equal to 0, less than or equal to 16. That's what we're going to put here. My maximum value is 16. My maximum is equal to 16. That's my maximum value. Here, let's cross this out. Just put maximum value 16. And this, write the words. For x is all real numbers. Good morning. Where was I? Okay, all real numbers greater than or equal to 0 and less than or equal to 16. That's our domain. And the reason why, just because the picture shows it going on and on, we know this is a soccer ball being kicked. So this will be considered underground. We know that James is not underground and kicked the ball, or underwater and kicked the ball. They don't say that. He's kicking a soccer ball and he's on top of the ground and then it hits the ground here. So that's why we limit it. We have 2 boundaries for domain. For the range, after the ball was in the air 16 seconds, it hit the ground. So it's all real numbers greater than or equal to 0 and less than or equal to 16. And that's just in this case that they both came out to be 16. The vertex indicates after 8 seconds it was at its maximum height of 16. And that's the range of our function. All right, now you're going to practice this on the next page, which is determine the domain and range for each equation. You're going to practice using your calculator to determine the domain and range. You want to place your answers on your answer document, which is here. I didn't write this here. I wrote it on the actual document, but here the answer. This will be where you have your answers from your micro lesson, and then you'll put your answers for your problems for your practice. So now you want to practice. Okay.